Everyone. Thank you for being here today. I am Aeshna Kapoor, a lead data scientist at BNY Mellon. It's a privilege to present my work that is titled Big Data Infrastructure Integrating Legacy Systems with AI-Driven Platforms. We'll explore how companies can modernize their data infrastructure by integrating AI with existing legacy systems. With organizations increasingly turning to AI to drive insights, they face a challenge. Many still rely on legacy systems, the backbone of their operations for decades. The question is, how can companies embrace AI without disrupting these core systems? So that's the puzzle we solve with the hybrid infrastructure model. Imagine a 30-year-old mainframe system responsible for processing millions of transactions in a major bank. Now, picture the same bank trying to integrate a real-time fraud detection AI system with this legacy platform. It sounds challenging, right? So the legacy systems such as IBM mainframes, Oracle ERP systems, or SAP are deeply entrenched in industries like banking, healthcare, and manufacturing. They are reliable, but often inflexible and unable to process the modern data flows efficiently. On the other hand, modern AI tools like Google Cloud AI, Azure Machine Learning, and TensorFlow offer unmatched capabilities for real-time analytics, predictive maintenance, and personalized services. However, these systems often speak different languages than the legacy platforms they need to integrate with. This brings us to the core challenge. How can organizations integrate AI without fully replacing the legacy systems? Replacing them is impractical due to high cost, operational risks, and disruptions it could cause. Our research offers a practical solution, a hybrid infrastructure model that enables the coexistence of these systems. Uh, so the paper has four primary objectives. First one is analyze, which is the understanding the architectural requirements for integrating legacy systems with the AI-driven platforms. For example, what kind of data models or middleware will allow a bank's core mainframe system to interact with an AI-powered fraud detection model. The purpose, which is to develop a hybrid infrastructure model that allows organizations to use both systems without major disruptions. This also explores so it identifies practical challenges, for example, how to ensure scalability when legacy systems weren't designed for high velocity data processing, and evaluates the benefits and risks. While this approach offers agility, it can introduce complexities, especially around security and governance. Let's dive into the heart of our solution, the proposed hybrid infrastructure. This model ensures seamless integration between legacy systems and AI-driven platforms. We achieve this through four key layers, each playing a distinct role in ensuring operational efficiency and technological innovation. The first one is our data integration layer. This layer acts as a bridge between legacy systems and AI platform by facilitating the data exchange. For example, a hospital's EMR system integrates with Google Cloud's Google Cloud's Health Lake via ETL pipelines to centralize patient data. So the new technology, AWS glue for data extraction and transformation. Data lakes like Google BigQuery to store structured and unstructured data for AI models. This layer ensures the legacy systems, which may store data in proprietary formats, can seamlessly understand that data into platforms that AI systems understand. Second is the microservices architecture. So legacy systems are broken down into modular microservices that can interact efficiently with modern tools. Example, a retail company's SAP ERP system can be containerized using Docker and managed via Kubernetes, enabling it to interact with AI-driven demand forecasting models. So the new technology here could be the Apache Kafka streams that streams real-time data between microservices and legacy systems, and Istio manages communication between microservices to ensure secure and efficient data exchange. So why it matters is because this is incremental transformation allows legacy systems to modernize gradually without disrupting daily operations. As the third one is the AI and machine learning layer. This layer offers advanced analytics and predictive capabilities to complement legacy systems. Um, the new technology that we can use here is the NVIDIA GPUs for faster AI model training, TensorFlow extended for deploying and managing production level AI models. By using AI here, organizations can generate insights that legacy systems could not produce on their own. The last one being the orchestration and the management layer. This centralized layer optimizes workflows, allocates resources, and monitors performances across legacy systems. Um, why it matters is because the orchestration ensures that hybrid infrastructures operate efficiently with resources allocated dynamically based on demand. Let's talk about now. Let's see how the data flows through this hybrid infrastructure in a real world example. So let's start with the ingestion. For example, a bank's core mainframe system sends daily transaction data to an ETL pipeline, say built with Apache Nifi. The data transformation, that pipeline that converts legacy data formats into JSON and Parquet files compatible with Google BigQuery. Then we move on to the AI model processing. The AI models on AWS SageMaker analyze transaction patterns to detect potential fraud. Then there is a feedback loop. The fraud alert is sent back to the mainframe and the system temporarily freezes the flagged account. The bank's operation team is notified immediately. The real-time reporting is using Tableau dashboards. The bank's analyst can monitor flagged transactions and overall fraud trends. Why this matters? This seamless data flow ensures that legacy and AI systems work together, with legacy platforms benefiting from the real-time insights generated by modern AI models. It reduces operational bottleneck and improve decision-making speed. Key challenges and solutions. While hybrid infrastructures offer many advantages, implementing them comes with a unique set of challenges. Let's explore these challenges in detail and the solutions we propose. The first one is data interoperability. Legacy systems store data in proprietary formats that are not compatible with modern AI platforms. The solution we propose is use the data transformation tools like opportunity to standardize data formats. Example, a healthcare provider converts HL7 data from its EMR system into JSON for analysis in Google Cloud AI. Second is scalability. The legacy systems were not designed for high speed, high volume data processing. So the solution we can propose here is offload heavy computation to cloud platforms like Amazon EC2 during peak loads. Example, a retailer with the legacy SAP system uses EC2 instances to manage increased traffic during Black Friday sales. Third is performance optimization. Ensuring optimal performances across both legacy and AI system is complex. Using AI-powered monitoring tools like Prometheus to detect bottlenecks. Fourth is our cost management. Integrating AI systems can be expensive, so prioritizing modernization of critical systems while leaving non-essential systems in legacy mode. So a bank modernizes its transaction systems but retains its legacy reporting systems to manage costs. The fifth would be our organizational resistance, sixth being our governance compliance. So why addressing these challenges matters? By proactively addressing these challenges, organizations can unlock the potential of hybrid infrastructures. This approach not only improves operational efficiency, also ensures long-term scalability and cost effectiveness. Now let's quickly take a look into some of the case studies here. Now, on how different industries have successfully adopted the hybrid infrastructure by integrating legacy systems with AI-powered platforms. These examples highlight the versatility and impact of such infrastructures across finance, healthcare, and manufacturing. I'm just going to go over some of the examples in finance. Examples say JP Morgan and Chase integrate AI models with the COBOL-based mainframe system to enhance fraud detection. The AI model monitors real-time transactional data and flags suspicious activity using anomaly detection algorithm on AWS SageMaker. If a suspicion transaction is detected, an alert is sent back to the mainframe system for immediate action. So the research insight here was the financial service companies are using machine learning-based predictive analytics to identify the fraudulent patterns that might evade traditional systems. AI-enhanced trading algorithms integrating the legacy core banking system helps bank optimize high-frequency trade and credit risk analysis. So the next step here would be a future research that focus on the automated fraud response system that autonomously halts suspicious transaction without human intervention. Let's move on to the security and compliance. Security and compliance are non-negotiable when integrating legacy systems with modern AI platforms. A hybrid infrastructure introduces potential vulnerabilities that need to be addressed proactively to ensure data security and regulatory compliance. Let's walk through the key aspects and the real-world scenarios. Data encryption. Data is at its most vulnerable when moving between systems, especially between legacy platforms and cloud-based AI systems. Encryption ensures that data remains secure both at rest and in transit. The second would be access control and role-based security. Third would be audit trails and activity monitoring. Fourth would be our compliance with regulation. Different industries must comply with strict regulatory standards that govern how data is handled and stored. Uh, Here we can use automated compliance tools like OneTrust or IBM Guardium, which continuously monitors hybrid systems for violations and send alerts if anomalies are detected. Let's revisit the key takeaways of the paper with an emphasis on the new research direction it promotes. This paper highlights that simply replacing legacy systems with modern AI platforms isn't feasible for many organizations. Instead, hybrid infrastructures provide a practical solution, enabling a phased modernization while retaining the stability of legacy systems. The unique contribution of this paper lies in several areas. New research areas promoted in this paper are the hybrid infrastructure models for seamless integration, AI orchestrated legacy systems with microservices, real-time analytics through edge AI and in Internet of Things integration. So the paper introduces Edge AI as an enabler for real time analytics, bringing intelligence closer to data. Sources like Internet of Things sensors. This is particularly new for industries still bound by legacy infrastructure such as manufacturing and healthcare. Fourth is our AI driven compliance and security monitoring for legacy systems. There's an emerging need here. Integrating legacy systems with AI introduces new security challenges. The paper proposes AI powered orchestration tools that offer automated compliance checks and real time security monitoring. The fifth is cost optimized hybrid infrastructure with cloud native solutions. Uh, Based on these insights, there are a few key areas that demand further research would be the automated orchestration tools, advanced governance tools, and some industry specific case studies. To conclude, the future belongs to organizations that embrace hybrid infrastructures, not as a compromise, but as a competitive advantage. The research presented in this paper opens up a path for gradual, cost effective modernization through AI by maintaining operational continuity. This balance between tradition and innovation is what will define industry leaders in the coming decades. Thank you.